Hello, algebra students. Mr. Lawrence here, and we're going to learn about the big F word today. Yeah, we're starting a unit on the big F word, which is factoring. Yeah, that's the big F word. All right, factoring. Now, we're going to do today what's called factoring by the GCF, which you already know. You already know this. We're just going to go a little more in depth. You know it because we used to call it undistributing. Undistributing. Yeah. That's what I've been talking about with undistributing. I've been holding off on using the big F word, but it's time for the big F word, so we're going to learn how to factor. We're going to learn a couple different types of factoring, and we're going to learn how to solve equations by factoring. But for right now, let's go ahead and just review how to factor by undistributing. Okay, so I'm looking at problem number one. It's a linear binomial, right? Remember that? Linear. Why is it linear? Because the highest power is 1 on the variable. And it's a binomial because there's two separate terms, right? Yeah, we got to review this. I know most of you don't have it. Make those flashcards up. This is a linear binomial. Now, to factor by GCF, I've got to find the GCF of my two terms. The GCF. All right, so let's see. The GCF of 25x and 10. Well, let me list here. 10, the factors of 10 are 1 and 10, and 2 and 5. And then I'm going to check and see, does 10 go into 25 evenly? Nope. Does 5 go into 25 evenly? It sure does. So 5 is part of the GCF. Now I'll check the variables. There's only an x over here. There's no variable over here, so I'm not going to have a variable as part of my GCF. Before we were undistributing, some of you were completely ignoring the variables. Don't ignore them, please. Please don't ignore them. Be nice to them. All right. In fact, I'm going to add a fourth problem here as I think about it. Now I'm going to do 36x to the 5th plus, let's see here, 18x to the 4th, and we'll subtract a 24x to the 3rd and see if you can get the GCF when it's time to get to that one. All right, now remember that distributing involves multiplication, so undistributing is going to involve division. So I'm going to divide by the GCF, but when I do that, that takes it out in front of a quantity. What's left inside of the quantity? What's ever left when I'm done dividing. Here, I'll do the hard part first. Look at this, negative 10 divided by 5, negative 2. Okay, 25x over 5. Well, I think that's going to simplify to a plain old 5x. And there you go, we just undistributed. We just factored out the greatest common factor of 25x and negative 10. All right, let's try this again. We've got 16x squared minus 8x. So I'm going to go looking for the GCF. I like to take the smaller of the 2 or 3 or 5 or how many ever numbers there are. This is a quadratic binomial, right? It's quadratic because it's the second power. And there's two terms, so it's a binomial. So I'm going to list the factors of 8. I'm going to have 1 and 8. And then I'm going to have 2 and 4. Then I'm going to ask myself, does 8 go into 16 evenly? Sure does. Part of my GCF is 8. Now look at this. I have an x squared, which is x times x, and I have an x over here. What do they have in common? Well, there's an x in common, right? This one has x times x, and this one has just x. So we're going to make our GCF 8x, not just plain old 8. 8 is a common factor, not the GCF. So I'm going to divide both terms by 8x. And when I do so, 8's going to go into 16 two times. X squared over x is x. So I'm going to have the 8x out front. Oops, I forgot it there. And inside, I'm going to have a 2x left, right? Because 16 divided by 8 is 2. X squared divided by x is x. Some of you were just like adding exponents here. Well, no, it's division. It's not multiplication. Then I'm going to subtract 8x divided by 8x. 1. 1, not 0. There you go. All right, let's try 2 more, and then you can get on to the video quiz. And again, you can watch this more than once. Please, please, please don't take a lazy approach. All right, so let's see here. I don't know if I gave myself enough room. Maybe I can move number 4 down here. Yeah, I'm going to get it out of my way. There we go. That should give me enough room to do it. Okay. So I'm going to go looking for the GCF of these three terms. I'll have GCF. Okay, I'm going to take the smallest number, the smallest coefficient, which is 2. So the factors of 2 are 1 and 2. Does 2 go into 16? It sure does. Does 2 go into 4? Yes, my GCF will have a 2 in it. Now I'm going to look at the variables. What's the greatest number of x's that are being multiplied together in all three terms? Well, this is x times x times x. This is x times x, and this is just an x. So the greatest number that they all have being multiplied is 1, a plain old x. So my GCF is 2x. So I'm going to divide all three terms by the GCF. And my GCF will go out front of the quantity. What's left? 2 divided by 2 cancel out. X cubed divided by x is x squared. 16 divided by 2 is 8. X squared divided by x, x. 4 divided by 2 is 2. X divided by x cancel out, and there we go. Now, by the way, I didn't mention that originally the problem, this 2x cubed minus 16x squared plus 4x, was a cubic trinomial. See, the third power and 1, 2, 3 cubic trinomial. Inside the quantity, I have a quadratic trinomial. There's 3 terms. Highest power is 2. All right, number 4. Number 4. All right, we're going looking for the GCF. All right, so I need to list the factors of 18. I'm going to start with them in 18. I'm going to go with 2 and 9. I know 3 and 6 are factors of 18, and then 4 doesn't go in, 5 doesn't go in. I don't need to check anymore. Remember to list them vertically in order like this as pairs. 1 times 18, 2 times 9, 3 times 6. It'll be a lot easier. So let's check them. Does 18 go into 36 evenly? It sure does. Does 18 go into 24 evenly? Nope. See, to be a common factor, it has to go into all the numbers we're talking about, not just 2 of them or 1 of them. Does 9 go into 36? It sure does. Does 9 go into 24 evenly? All right, let's try 6. Does 6 go into 36? It does. It goes into 18, of course. Does it go into 24? You betcha your life. There we go. GCF has a 6 in it. Now, what's the greatest number of x's that are included in each term? Well, I have x times x times x times x times x. This is x times x times x times x. And this is x times x times x. Looks like they have 3 in common. Hey, I'm remembering something I said to you when we were on distributing. I said the GCF of the variables would always be the smallest exponent. Yeah, look at that. It's x cubed, isn't it? Isn't the smallest exponent of the x's cubed? Right? X to the 5th, x to the 4th, x to the 3rd, or x cubed. There's my GCF. So I'm going to divide all 3 terms by x, 6x cubed, 6x cubed, and 6x cubed. So my 6x cubed is out front. What's left in the quantity? 36 divided by 6 is 6. X to the 5th divided by x cubed is x squared. 18 divided by 6 is 3. X to the 4th divided by x cubed is x. 24 divided by 6 is 4. The x cubes cancel out, and there you go. Initially, I had a 5th degree trinomial, and now I have a quadratic trinomial, right? There we go. All right, one more. Let's do one more strange example. Let's do one like this. Let's do 40, x to the 6th, y to the 2nd, z to the 8th, minus, let's go with 24, x to the, let's go with x to the 5th, y to the 6th, and z to the, let's not go 7, let's go z to the 3rd, z to the 3rd. Okay, so again, I go looking for my GCF. GCF. All right, it's going to take the 24. I'm going to list the factors of 24. 1 and 24. 2 and 12. 3 and 8. 4 and 6. 5 doesn't go in. Now I'll compare the factors of 24, starting with 24 to 40. If they're factors, great. I've got the greatest common factor. If it's not, I'll cross it off. So is 24 a factor of 40? Nope, it is not. Is 12 a factor of 40? 8 is a factor of 40. So my GCF, I guess I shouldn't write GCF there, sorry, is going to have an 8 in it. Now let's check the x's. Okay, I've got x to the 6th and an x to the 5th. I'm going to highlight those. X to the 6th and an x to the 5th. Well, the highest or the lowest degree is x to the 5th. Hey, could I think about x to the 6th as x to the 5th times x to the 1st? And this would just be an x to the 5th times 1. Yeah, so you see they have an x to the 5th in common. Okay, how about the y's? Well, let's highlight those y's. There we go, y squared and a y to the 6th. The GCF of the y's is going to be y squared. Y squared. All right, and then the z's, I have a z to the 8th and a z to the 3rd. So that will get me a z to the 3rd. The GCF of the variable is always the least exponent. So I'm going to divide by 8x to the 5th y squared z cubed and divide by 8x to the 5th y squared z cubed. All right, so my GCF goes out front. And then I'm just going to divide. What I get when I divide, that's what will be left inside the quantity. 40 divided by 8 is 5. X to the 6th. X to the 6th divided by x to the 5th should be a plain old x, right? Y squared divided by y squared, they cancel. Z cubed, z to the 8th divided by z cubed is going to be a z to the 5th. Over here, 24 divided by 8 is going to be 3. X to the 5th cancel. Y to the 6th divided by y squared is going to be a y to the 4th. And the z cubes cancel. And there you go. All right. Here comes the video quiz. Now, if you don't quite get it, go back and watch it again. There's only 2 problems. Okay, show all your work. And I will say that's it for tonight. Have a nice weekend, everybody. Mr. Laurence signing off.